Hello, this is Sanket Thackeray and you are watching Sanket Thackeray YouTube channel. We covered control system 1 root locus topic in this video. So let's start. We see here the first problem of this root locus. State the root locus for open loop transfer functions g of s into h of s equal to k upon s into s plus 3 s square plus twice s plus 2. First step is here. Root locus is symmetrical about real axis. We have to check first in axis, so we can check here. Then we write in first step root locus is symmetrical about real axis. Then next second step number of points, that is 4, and m equal to 0. Then we search points of that point 4, s1 equal to 0, s2 equal to minus 3 and s3 equal to minus 1 plus minus j1. स्टेप नंबर 3 में जाएंगे. उसके बाद देखेंगे कि 0 and minus 3 are the root locus. Then step number 4 number of asymptotes. नंबर ऑफ एसिम्प्लॉट्स निकालने के लिए फॉर्मूला है n माइनस एम इक्वल टू 4 माइनस 0 इक्वल टू 4. By value putting in that formula we get number of asymptotes. Next we see the value of phi 1, that is 180 degree into 2 cube plus 1 upon n minus 1, that is formula, and by putting in that formula value we get phi 1, that is 45 degree, phi 2 135 degree, and phi 3, that is 224 degree, and phi 4, that is 315 degree. Then next step we go to step number 5, centroid. We have to find centroid point. So for that centroid we use this formula. By rules we see in by rules see in class sigma a. By putting this value we get minus 1.25. After that we go through step number 6, angle of departure minus 1 plus j1. Then we put up formula and value, so we get minus 70 degree. Then next we go through step number 7, phi dp minus 1 minus j1 equal to plus 70 degree. Then step number 7, breakaway point 1 plus k upon s into s plus 3 s square plus twice s plus 2 equal to 0. So we solve this and we get last equation 6s to the power 4 5s cube 8s square plus 6s plus k. That's the equation. Then next we have to find the roots of that equation. So we get roots of that equation, that is sb1 equal to minus 2.28, sb2 comma 3 equal to minus 0.73 plus minus j1. So we have to find direction. So for direction we check for formula 180 degree upon r, and then we get r equal to 2. So next step is step number 8, that is point of intersection on jw axis. So equation is that s to the power 4 plus 5s cube plus 8s square plus 6s plus k equal to 0. By Routh's criteria, we get s to the power 0, s to the power 1, s to the power 2, s to the power 3, s to the power 4. We take that and then write variable like that: s to the power 4 1, then 5s cube 5, then 8s square 8, then 6s 6, then plus k and then 0. Then we cross multiply it and we get the value of s square 6.8. After that we take this 40.8 minus 5k upon 6.8 equal to 0. 40.8 minus 5k equal to 0, minus 5k equal to minus 40.8, then k equal to minus 40.8 upon minus 5. So we get k max, that is 8.16. So after that we arithmetic we take arithmetic equation is 6.8 s square plus k max equal to 0. So 6.8 s square plus 8.16 equal to 0. So we get s1 comma 2 equal to plus minus j 1.1. So system is stable in the region 0 less than k less than 8.16. So after that we see the total graph of that. We take it as a zoom position. We see here x-axis and y-axis. In that position we take x-axis 0, minus 1, minus 2, minus 3, minus 4, minus 5, and on y-axis minus j4, minus j3, minus j2, minus j1, and middle point 0. After that we see angle of asymptotes. So in that position we take all angles and draw the root locus. In that position we see the root locus point, that is a centroid point, minus on the position of minus 1, sigma a equal to 1.25, and we draw here line and then breakaway point, take it at a minus j 1.1. So root locus going through that point, and after that we get point more than 2.28 HB1. So we draw here root locus, and such a root locus is drawn here on graph, and then convert it into a total root locus system. For that we see root locus position to get system is stable or not.